Our story doesn't begin on this planet. It doesn't start in a city, a nation, or even with the first flicker of life. Our real story starts in darkness and chaos, 4.6 billion years ago. In a vast, cold corner of the Milky Way, a giant cloud of gas and dust held all the raw ingredients for everything we've ever known. It was just sitting there, dormant, until a nearby star died in a cataclysmic explosion. A supernova, sending a shockwave of creation through the cosmos. That shockwave slammed into our stellar nursery and triggered the single most important event in our history: the beginning. This is the story of how cosmic violence, planetary collisions, and frankly impossible odds transformed a simple cloud of dust into our home, and ultimately into you. Before Earth, there was just a nebula, a vast, shapeless cloud of hydrogen, helium, and the dust of long-dead stars. The supernova shockwave was the trigger, the cosmic push that caused this cloud to start collapsing under its own gravity. Think of a snowball effect on a galactic scale. As more gas and dust got pulled inward, the center grew denser and hotter. Its gravitational pull got stronger, pulling in even more material. Over about 100,000 years, this collapsing cloud flattened into a spinning disk, sort of like spinning a lump of dough into a pizza base. This was the protoplanetary disk. At its heart, where an almost unbelievable 99.9% of all the matter was concentrated, a protostar began to form. Over the next 50 million years, as it gathered more and more material, the pressure and temperature in its core climbed to unimaginable levels until it finally hit the ignition point. Nuclear fusion began. In a brilliant flash, our sun was born, and for the first time, light flooded our brand new solar system. With the sun as the anchor, the leftover 0.1% of the disk is where the rest of the story began to unfold. This disk wasn't the same all the way through. Close to the sun, it was a furnace, where only heavy materials with high melting points like metals and rock could become solid. Further out, beyond a crucial boundary we call the frost line, it was cold enough for lighter stuff, water, methane, and ammonia to freeze into ice. This simple temperature difference would decide the fate of every planet. Now, you might think the small rocky planets would form first, but it was actually the giants. Within just a few million years, out in the cold zone beyond the frost line, Jupiter and Saturn took shape. Tiny grains of ice and rock stuck together, growing into pebbles, then boulders, then planetesimals, bodies kilometers across. These planetesimals collided and merged, their gravity growing with their size, allowing them to hoover up the immense amounts of hydrogen and helium gas just sitting out there. Uranus and Neptune followed a bit later, within about 10 million years, becoming the ice giants we know today. The age of giants was fast and decisive. Closer to the sun, inside that frost line, making planets was a much slower and more brutal process. There was just less solid material to work with. For nearly 100 million years, dozens of small rocky protoplanets, ranging in size from our moon to Mars, battled for space in a chaotic orbital dance. They smashed into each other, merged, and grew in a process of violent creation. Out of this planetary demolition derby, 4 winners emerged: Mercury, Venus, Mars, and a young molten world called Earth. But Earth's most important moment was still to come. Around 4.5 billion years ago, another world, a Mars-sized protoplanet we now call Theia, was on a collision course with our own. The impact that followed wasn't a simple merger, it was a world-shattering cataclysm. Theia slammed into Earth at a glancing angle, vaporizing itself, and a huge chunk of Earth's crust and mantle, a colossal ring of molten rock and debris, was blasted into orbit. Gravity worked its magic once more. And over a shockingly short time, maybe only a few tens of thousands of years, this debris pulled itself together. It became our constant companion, a world born from our world, the moon. This giant impact hypothesis explains why the moon is so big compared to Earth, and why its composition is so similar to our planet's mantle. The solar system was still a total mess. For hundreds of millions of years, it was a cosmic shooting gallery. Between about 4.1 and 3.8 billion years ago, the giant planets, Jupiter and Saturn, started shifting their orbits. Their massive gravity acted like a slingshot, flinging the leftover junk from planet formation, asteroids, and comets in every direction. This period, known as the Late Heavy Bombardment, subjected the inner planets to a relentless assault. The surface of the early Earth was a hellscape of erupting volcanoes and constant impacts. But this violence was also a delivery service. While much of Earth's water was already here, trapped in the rocket formed from and released as steam by volcanoes, this bombardment topped off the tank. The comets and asteroids that scarred our planet's face were rich in water ice and organic compounds, the essential ingredients for life. They were galactic couriers, turning our scorched rock into a water world. As the bombardment finally started to die down around 3.8 billion years ago, the Earth was sterile, but it was ready. In the warm, shallow, nutrient-rich oceans, something miraculous happened. We don't know exactly how or when. Some evidence suggests it could have been even earlier, maybe 4.1 billion years ago, but simple organic molecules delivered by comets and cooked up in deep-sea hydrothermal vents began to organize themselves. They formed self-replicating structures. The first life emerged. For over 1 billion years, these simple, single-celled organisms had the entire planet to themselves. Then, around 2.4 billion years ago, a revolutionary new microbe evolved, cyanobacteria. These tiny organisms figured out a radical new way to harness the sun's energy, photosynthesis. In doing so, they started releasing a waste product, a gas that was toxic to almost all other life on the planet, oxygen. This kicked off the Great Oxidation Event. For millions of years, this oxygen was absorbed by iron in the oceans, creating the vast bands of rust we now see in rock layers. But eventually, the oceans couldn't hold anymore. Oxygen flooded the atmosphere. It caused a mass extinction of organisms that couldn't handle it, but it also created the breathable air we depend on and formed the ozone layer, which shields the surface from deadly solar radiation. The stage was set for a new, more complex kind of life to take over. For another billion years or so, evolution seemed to slow down in a period sometimes called the boring billion. But under the surface, the genetic toolkit for complexity was being assembled. Then, about 540 million years ago came the Cambrian explosion. In what was a geological blink of an eye, life went from simple to spectacular. The first animals with skeletons, shells, and eyes appeared. Ancestors of nearly every animal group alive today burst onto the scene in a frenzy of evolutionary innovation. Trilobites scuttled across the seafloor, while strange creatures like the five-eyed opabinia hunted in the ancient seas. Life conquered the oceans, and then the land. Plants went first, followed by insects and amphibians. This led to the age of reptiles, and ultimately to the undisputed kings of the planet, the dinosaurs. For 150 million years, they dominated every continent. They were the pinnacle of evolution, and they seemed invincible. Of course, the universe had other plans. 66 million years ago, a 6-mile-wide asteroid traveling at 40,000 miles per hour slammed into the Yucatan Peninsula in Mexico. The impact released the energy of millions of nuclear bombs, triggering global tsunamis, continent-spanning firestorms, and throwing so much debris into the atmosphere that it blocked out the sun. Photosynthesis stopped, food chains collapsed, and around 75% of all species on Earth were wiped out. It was the end of the dinosaurs. This incredible, violent, and beautiful story is etched into the very fabric of our planet and written in our DNA. If this journey through deep time gave you a new perspective on our world, consider liking this video and subscribing for more stories about our amazing universe. And let us know in the comments, what part of Earth's history blows your mind the most? The extinction of the dinosaurs was a tragedy, but it was also an opportunity. With the giants gone, a small, shrew-like group of survivors emerged from the shadows, our ancestors, the mammals. Over the next 66 million years, they diversified, filling every empty ecological niche. Primates evolved, and from them, the great apes. Then, in a small corner of Africa, our own branch of the story truly begins. A line of apes started to walk on 2 legs. Their brains grew larger. They developed tools, language, and culture. If you imagine Earth's entire 4.6 billion year history as a single 24-hour day, the first life appears around 4 a.m. The dinosaurs roam from about 10 p.m. until just before 11:41 p.m. All of recorded human history, every king, every battle, every invention, every love, every loss, is contained in the final single second before midnight.